You ever walk into a building and wonder, how in the heck is this thing standing? That's where structural engineering comes in, folks. It's the magic behind those towering skyscrapers, those impressive bridges, and even your humble abode. Simply put, structural engineering is all about making sure things don't fall down. We're talking about designing structures that can withstand all sorts of pressures and forces, from howling winds to heavy loads. It's about creating buildings that are safe, sound, and built to last. Think of it like building with Legos, but on a much larger scale, and with way higher stakes. Instead of plastic bricks, we're talking steel beams, concrete columns, and a whole lot of math. But the basic principle is the same. It's about understanding how different elements work together to create a strong, stable structure. So the next time you're marveling at an architectural wonder, take a moment to appreciate the structural engineers who made it possible. They're the unsung heroes who keep our built environment standing tall. Structural engineers are like the doctors of the building world. They examine blueprints, analyze loads, and figure out how to make structures safe and sound. They're the ones who make sure your house can handle the weight of your roof, or that a bridge won't buckle under the weight of traffic. These folks are problem solvers, using their knowledge of physics, math, and materials to design structures that can withstand the test of time. It's a demanding job, no doubt, but it's also incredibly rewarding. After all, these are the folks who are literally shaping our world, one building, bridge, and tunnel at a time. Now let's talk about forces. No, not the Force from Star Wars, but the forces that act on structures every single day. We're talking about things like compression, tension, shear, and bending. Compression is like what happens when you squeeze a sponge. It's a force that pushes or presses an object together. Tension, on the other hand, is like stretching a rubber band. It's a force that pulls or stretches an object apart. Shear is a force that acts parallel to a surface, like when you spread a deck of cards. And bending is a combination of both tension and compression, like when you bend a ruler. Understanding these forces is crucial for structural engineers. They need to know how these forces will impact a structure in order to design it properly. It's like playing a giant game of Jenga, but with much higher stakes. Just like you wouldn't build a house out of playing cards, you wouldn't build a skyscraper out of popsicle sticks. Choosing the right materials is crucial in structural engineering. It's about finding that perfect balance between strength, durability, and cost. Steel, for example, is incredibly strong and can withstand heavy loads. That's why it's often used for skyscrapers and bridges. Concrete, on the other hand, is great for foundations and walls. It's strong, durable, and relatively inexpensive. Then you've got wood, which is a renewable resource and surprisingly strong for its weight. And let's not forget about composites, which are materials made up of two or more different materials, like fiberglass or carbon fiber. Choosing the right material depends on a lot of factors, like the type of structure, the loads it needs to withstand, and the environment it's in. It's all about finding the material that's best suited for the job. Section 5. Touching the sky, designing a skyscraper. Let's say you're tasked with designing a skyscraper. Where do you even begin? First, consider the loads. Skyscrapers must withstand wind, seismic loads, and the weight inside. Then, think about the foundation. A strong foundation prevents sinking or tilting. Next, the structure itself. Skyscrapers use steel, concrete, or both. The structure must support weight and resist lateral forces. Don't forget the building envelope. It must withstand elements and be energy efficient. Designing a skyscraper is complex and requires creativity. Section 6. New heights. Modern challenges in structural engineering. The world of structural engineering is constantly evolving. New materials are being developed, new construction techniques are emerging, and the demands on our built environment are constantly increasing. One of the biggest challenges facing structural engineers today is sustainability. We need to find ways to build structures that are not only strong and durable, but also environmentally friendly. This means using sustainable materials, reducing waste during construction, and designing buildings that are energy efficient. Another challenge is resilience. As our climate changes, we're seeing more extreme weather events like hurricanes, earthquakes, and floods. Structural engineers need to design structures that can withstand these events and protect the people inside. And then there's the challenge of urbanization. As more and more people move to cities, we need to find ways to build taller, denser, and more efficient structures. This means pushing the boundaries of structural engineering and coming up with innovative new solutions. Section 7. Greener Buildings, Brighter Future Sustainability in Structural Engineering. Sustainability isn't just a buzzword, it's a necessity. And in the world of structural engineering, it's changing the way we design and build. We're not just talking about using recycled steel or planting trees around a building, although those are good things. We're talking about a whole new mindset. Imagine a skyscraper that generates its own energy with solar panels or wind turbines integrated into its design. Picture bridges built with concrete that actually absorbs carbon dioxide from the air, helping to clean up the environment. That's the promise of sustainable structural engineering. It's about finding innovative ways to reduce the environmental impact of our built environment, from the materials we use to the way we design for energy efficiency. And it's not just good for the planet, it's good for business. Sustainable buildings can save money on energy costs, attract tenants who are environmentally conscious, and increase property values. It's a win-win situation for everyone involved. Section 8. Building Toward Tomorrow, the Future of Structural Engineering. So, what does the future hold for structural engineering? Well, one thing's for sure, it's going to be exciting. With advancements in technology, materials, science, and our understanding of the natural world, the possibilities are endless. Imagine self-healing concrete that can repair its own cracks, or buildings that can adapt to changing environmental conditions. Picture structures that are built by robots, or even three-dimensional printed on site. We're on the cusp of a new era in structural engineering, one where innovation and creativity will shape the world around us. And as we face the challenges of the future, from climate change to population growth, structural engineers will be at the forefront, designing the solutions that will shape our world for generations to come.